Hi, we will be recording videos on the differentiation of various functions. And in order to do so, we need to establish or record this video on the basic differentiation rules. What happens when we add function, do the derivative of a sum, of a subtraction, of a multiplication, etc. Okay, so this is a prior video to do before I record most of the differentiation rules for the basic function. Okay, what I want you to remember is that the derivative is basically the slope, and it's being calculated by a limit. Mathematicians calculate the limit of each function, and they create a general rule for each function and for each mathematical operation. And it's better for us to learn that to learn the table of the derivatives, the rules for each differentiation, instead of having to do this mathematical operation on each one of them. Okay, so the sum rule. If we have two functions and we have to do the derivative of two functions that are added together, well, mathematicians have done the limit of the slope and the limit of that slope for a sum of functions, and they've discovered, and this is what we have to learn, that this is the derivative of each function separate, and then we can add those derivatives. So the derivative of the sum of functions is the sum of each derivative. Okay, fortunately. Okay, you can imagine that the subtraction follows a similar pattern, and if we have the subtraction of two functions, then we can do the subtraction of each derivative. Okay, multiplication. Here we have to learn a rule, the multiplication rule, but it is very easy, so follow me through this. If we have to do the differentiation of the multiplication of two functions, the rule that we have to learn, but you will learn it very easily because we use it a lot, is that first we do the derivative of the first function and multiply it by the second function without the derivative, and then we add the multiplication of the first function without doing the derivative, multiplied by the derivative of the second function. So it's as if you do first the first one multiplied by the second one, plus the first one without the derivative and multiplied by the second one, the derivative of the second. Okay, it's very easy to remember, as you can see. Then the division. Okay, what happens with the division? Well, I sometimes use the formula I'm going to give to you now, and sometimes if I have the division of functions, depending on what comes handier, I change this, I rewrite the division as a multiplication. Okay, so sometimes in a division I use the multiplication rule with the denominator written as to the power of -1. Sometimes it's easier for me to do it this way, and sometimes I use the rule that I'm going to give you here, which is also, you should also learn. When do I do each thing? Well, I'll record some videos on multiplication and division with examples, and you'll see. What is the rule of the division then? So if you have to do the differentiation of the derivative of a division, so it's the numerator, the differentiation of the derivative of the numerator multiplied by the denominator without doing the derivative, minus the numerator as it was without the derivative, multiplied by the derivative of the denominator, and all that. Wait a second, I'm going to write that better. Okay, so that there's no confusion. All that divided by the denominator to the power of 2, denominator squared. So it's, as you see, the top part is like the multiplication. So it's the first one, the derivative of the first one multiplied by the second one without doing the derivative, minus first one times derivative of the second one divided by the denominator squared. Okay, and then we have the composition of functions, which is also called the chain rule when you do the derivative. What is a composition of function? I'll do a short reminder of this. So we used to write the composition of function as as this, okay, which can also be written as this, okay. And I know this frightens you when you see it, but it's fairly common. Imagine you have sine of x cubed, okay. So this can be considered as two functions. One is the sine of x, the other one is x cubed, and we have done f composite of x of g dx, okay, where we have done sine of x cubed, okay. This was f, this was g dx, okay. So the chain rule says that if I have to do the derivative of the composition of two functions, what I do is I do the derivative of the external function, ignoring the internal one, and I multiply it by the derivative of whatever is inside, okay. So for example, I'm not going to do it because we still don't know the derivatives, but if we have to do the derivative of sine of x cubed, we can do sine of x cubed, okay, as the derivative of the sine multiplied by the derivative of x cubed. And we'll see how we do this in a video of composition of the composition of functions, okay. So and the last rule we need to know, and it's a very important one, is the multiplication by a scalar. So if we have the derivative of a function multiplied by a number, a is a number there, the mathematicians doing operations have discovered that this is the same as doing the multiplying the number by the derivative of the function. Okay, so it's as if the number could be extracted from the derivative. Okay, written in another form, if we have a times fx derivative, so it's a times f prime of x. So it's as if the number can be extracted from the derivative when it's multiplying, and then we can ignore the number and do the leave it multiplying and do the derivative there. Okay, so we need this basic rules. Remember, the sum rule is the sum of each derivative. Subtraction rule, the subtraction of each derivative, which means that the derivative operation is linear. So the multiplication is first we do the derivative of the first one times the second one, plus the first one times the derivative of the second one. Division, we can change it into a multiplication, or we can do numerator, the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator divided by denominator squared. The composition is the chain rule. The derivative of the composition of two functions can be the derivative of the external one times the derivative of the internal one. And the multiplication by a scalar, multiplication by a number, we can extract the number outside and do the number times the derivative of the function. Okay, so I hope this helps, and then from this, once we've recorded this video, then we can go into the rest of the derivative of the rest of the functions.